So today we're going to deal with phase shifts and sinusoidal function of the form a sine omega x minus phi or phi, depending on if you're from East Texas or not, plus b. Okay, so omega and phi, those are Greek letters. P-H. I, phi. Okay, and so these just represent real numbers. All right, so the amplitude here is the absolute value of A. Now, trying to figure this out, now what do we know? We know that the sine curve has period 2 pi, right? So if I have what's in the argument here, omega x minus phi, okay, well, I know one period is stuck between 0 and 2 pi. And now if I solve for x, I add phi. Okay, so I have phi, and then omega x less than or equal to 2 pi plus phi. And now divide by omega, and divide everything by omega. And so what does this tell me? All right, it tells me that we begin our period with phi over omega, and we end our period with phi over omega plus 2 pi over omega. Okay, which totally makes sense if you had, omega sine or sine of omega x, then that period would be 2 pi omega. Okay, so maybe that helps you understand where these pieces come. All right, if you look at this on a graph, maybe we're starting at phi over omega, and so we're going through a full cycle, one period, and this is phi over omega plus 2 pi over omega, right? The phase shift, this distance here shifted, that's the phase shift that we're talking about. All right, so we're shifting the graph, that distance, that's our phase shift, right? So the phase shift is this phi over omega distance here. Okay, so how would you get that in there? You take this a sine omega x minus phi plus b. I'm going to factor out. I'm going to factor out an omega. So I pull the omega out. What do I have? I have x minus phi over omega in here plus b. Okay. So keep that in mind as you go about doing these. If you have a coefficient in front of your x here, you're going to have to factor that out as you work through the problem. Say it's like the sine of 2x plus 3, okay? This would be the sine of 2 times parentheses x plus 3 over 2, okay? So this tells you your phase shift, how far you go left or right. In this case, in particular, with a plus inside, you're going to be shifting it to the left, right? And the omega outside here, that's your speed, right? That's how quickly you're flowing through. Okay, so in general, our y equals a sine omega x minus phi, or y equals a cosine omega x minus phi. Okay, so the amplitude is equal to the absolute value of a. The period, okay, this is t, which is equal to 2 pi over omega. And the phase shift, how far you shift left or right, this is equal to phi over omega. All right, so the phase shift is to the left if phi is negative, and the phase shift is to the right if phi is positive. Okay? So I guess I could write that out. If phi is negative, shift to the left. If phi is positive, shift to the right. All right, so you got to be careful here, because like this one, you might say, well, look, phi was positive. But really, what does your formula say? It says minus phi, right? So technically, this is like saying sine of 2 and then parentheses x minus a minus 3 over 2. Remember that from college algebra? The way to add something via negative is to minus a minus. Okay, so technically your phi here is negative. That's why you're shifting to the left. Okay, so be careful on that. All right.